Good morning, students. Here we begin with the next topic, that is altitudes and median of a triangle. The very first thing that we are going to discuss is about angle bisector and perpendicular bisector. Okay. So what are angle bisector? The line which passes through the vertex and lands up on the opposite side of a triangle and divides the angle into two equal parts. That is known as angle bisector. Right. So here QB is known as angle bisector. Right. RA is known as angle bisector and PC is known as angle bisector. Okay. Now these angle bisector intersect each other at one point. That point I have denoted it by I. Okay. That point is known as in center. What is that point known as? In center. Now there are certain identical marks which tells us that the angle is divided into two equal parts. Okay. So these are the angle bisector which intersect at point I, and this point is known as in center. Now we come to the next part. Now what do you observe over here? You will be observing that a few lines are been intersecting at point C. Now when you see at point D, here a perpendicular sign is drawn, and this line, that is D M, I will take. Okay. So this DM is dividing ST into equal parts. Here it is dividing into equal parts. Similarly, this line, that is, I'll name it as EN, right? EN is perpendicular to TU, right? And this NE is dividing TU into two equal parts, that is TE is equal to EU, right? Similarly, SU is divided by line CF, I can say, okay? Here it is making an angle of 90 degree, and here it is dividing SU into two equal parts, right? Now here these lines which are perpendicular to the side and dividing the side into two equal parts are known as perpendicular bisector. What are they known as? Perpendicular bisector. Okay. Now these perpendicular bisector meet at point, okay, that point I have denoted by C. Okay, and this point is known as circumcenter. Okay, now wherever this angle bisector or perpendicular bisector meet, okay, that point is known as point of concurrence. What is that known as? Point of concurrence, and these points are named by certain name, that is in center and circumcenter. That is in center and circumcenter. Okay. Now here one of the activity we have to do, next we have to do is we have to draw a perpendicular to line L from point P, which is not on the line, by using the set square. So this is what is the set square. There are two types of set square. This is equilateral triangle and the other one is right angle one. Okay. So we'll be using this equilateral one. Any one you can use. Okay. So that one of the side of this set square coincides with the line L, so that the perpendicular comes on point P. Okay. Now what I'll be doing, I'll be dragging this set square towards the point P so that it coincides with the side of the set square, which is making which is perpendicular to the line L. Okay. So here I'll be drawing a line passing through it. Okay. It's not clear. Here it is making an angle of 90 degree. You can measure it with the help of your D, or you can call a protractor. Fine. See, is it making an angle of 90 degree? Yeah, it is making an angle of 90 degree. Means it is perpendicular, which is drawn from the point P to the line A. This is one of the activity that you have to do. What it is? I hope I am clear now. So what are altitudes now? Altitude is the perpendicular segment drawn from a vertex of a triangle on the side opposite to it is called as altitude of the triangle. Okay. Now here, this altitude is also known as height in common language. Okay. With the help of the diagram we are going to see. So here I am drawing a triangle ABC. Okay. Now here this is triangle ABC. A is the opposite vertex to BC. Similarly, B is the opposite vertex to AC and C is the opposite vertex to AB. Okay. Now from point A, if a perpendicular is drawn to the opposite side of it, okay, then this AP is known as altitude. Fine. Now, a perpendicular drawn from a vertex of a triangle on the opposite side of it is called an altitude of the triangle. Fine. In triangle ABC, segment AP is an altitude to the base BC. Now to draw altitude of a triangle. For this we will need a triangle over there. So I'll be drawing a triangle. Now here we have to use set square to draw the altitude of the triangle. So I'll name this triangle as Y, Z and X. Okay. Now set square we have to use. So we have to use the activity what we have done. Okay. To draw the perpendicular to the line from the point outside the line. Okay. So Y is the point which is outside the line, X, Z, X. Okay. So I'll be drawing a perpendicular from this vertex. Fine. So here it will be drawn a perpendicular. I'll name it as Q. So AQ is a perpendicular drawn on ZX from vertex Y. Fine. In same way, I'll be drawing the altitude from X which will land up on ZY. Okay. Here it is a perpendicular drawn. Fine. Then with the same way I'll be drawing perpendicular to YZ, right, from point Z. YX from point Z. So here it is a perpendicular, right? Now all these altitudes are meeting at one point. That point is named by O and that point is known as Orthocenter. What is that point known as? Orthocenter. So we are going to write the definition for orthocenter. the point of concurrence is called orthocenter of the triangle. It is denoted by the letter O. Now we are going to discuss about the location of orthocenters of different types of triangles. Now we are aware of the types of triangles. They are right angle triangle, obtuse angle triangle and acute angle triangle on the basis of their angles, right? Now when I am talking about right angle triangle, means it is making 90 degree at one of its vertex, okay? So AB and BC are perpendicular to each other, right? So the vertex, the altitude of BC will be AB and the altitude of AB will be BC, okay? Now we have to just draw the altitude of AC over here by using the set square. So if I draw the altitude of AC, just see the position how I have kept my set square. The same way you have to keep for right angle triangle. Now here I am drawing. Fine. Now this I'll name it as D. It is perpendicular over here. So BD is meeting at point B. BC is meeting at point B and AB is at point B. Means all the three are meeting at point B. Fine. So this point B is the orthocenter of the right angle triangle ABC. Now from this in general if we conclude, so what it will be, the orthocenter of a right angle triangle is the vertex of the right angle triangle. This will be the statement. I hope it is clear. Now the next one is obtuse angle triangle. I'll name this triangle as L, M and N. Okay. Now here triangle LM I have extended further and MN I have extended further to get the altitude over here. Okay. The point of concurrence over here. Fine. So we are going to use the set square to locate the orthocenter of obtuse angle triangle. Okay. Now what I'll be doing, I'll be placing the set square on LN such that it makes a right angle at LN and it passes, name it as AB, one of the ray, I'll name it as AB. Here it is making 90 degree. Now what I'll be doing, I'll be placing this on this line, okay? On this line straight I have placed, see. Now what I'll be doing, I'll be just pulling it down so that the vertex I may get. So I'll just draw this line and then I'll extend further, okay? I'll pull this down. I'll name it as MNC. Fine. Now here, now this line MN, for this I have to draw the altitude from L. Okay. So see how I have placed my set square over there. So on this line I'll be sliding so that I may get point L. perpendicular to the line. So here it is. Then what I'll be doing, I'll be pulling this down so that I may extend further. So for line MN, side MN, I'll be drawing the altitude from point L. So what I'll be doing, I'll be sliding this way. Okay. And I'll be drawing a line passing through it. Then further, I'll be extending it. See, it's intersecting. See, it is intersecting at one of the point. Okay. This I'll name it as C. This I'll name it as D because C I have already taken over here and it is perpendicular over here. Fine. And this point is known as point of concurrence. Okay, which point? Point O is known as point of concurrence. I hope I am clear. Okay. So from point LN, this is the perpendicular drawn. Okay, AQ. From line LM, the perpendicular drawn is NC. And for line MN, the perpendicular drawn is ND. All the three rays are meeting at point O. This is known as orthocenter. Now, in general, if we have to write the orthocenter, which is this triangle? Obtuse angle triangle. Okay, so where is the orthocenter of the obtuse angle triangle lying? It is lying outside the triangle. Okay, so in general, if we have to write, what we are going to write? The orthocenter. So the altitude of obtuse angle triangle is meeting outside the triangle. Triangle LMN is an obtuse angle triangle and its altitude is meeting at point O. Okay, they are intersecting one another at point O. So in general, if we have to write, the orthocenter of an obtuse angle triangle is in the exterior of triangle. Okay, that is acute angle triangle. Okay, we will be using the set square over here. So I'll name this triangle as XYZ. So for YZ I have to first draw. So from X I'll be drawing. You have to be careful whether it is making a right angle or not. Okay. Then from Z I have to make. See that XY coincides with the one of the side of the set square. Yes, it is coinciding. So I'll name this as XP. And from here I have to draw now. So it's easy to draw for right angle triangle and for acute angle triangle. Little tedious is for obtuse angle triangle, but by practice you can do it. So here it is O, this is Q and this is R. So all the altitudes meet at point O. Now where is this point O lying for acute angle triangle? It is lying inside the triangle. Okay. So in general, if I have to write, what I am going to write? The orthocenter of acute angle triangle is in the dash of the triangle. So what will come in the dash? Interior of the triangle. Okay. Now the angle bisector, perpendicular bisector, altitude, median are known as cVns. What they are known as? Seviance, it's not in your book, just for your general knowledge it is, okay. The altitude of a triangle passes through exactly one point, okay. The altitude of the triangle passes exactly through one point, okay. That means they are what? They are concurrent. What are they? Concurrent, okay. The point of concurrence is called the point of concurrence of what? Of altitude, okay. Of altitude is called the orthocenter. What is that known as? Orthocenter, and is denoted by letter O, right? Now your triangle LMN is given to us, okay. We have to specify in triangle LMN dash is the altitude. Now which is the altitude over here? Find out. So whichever, now your XY, is it an altitude? No. Why? Because it is not perpendicular to MN. So which is the altitude? Altitude is LX. So here you are going to write segment LX is an altitude. I hope it is clear. Now we move on to the next problem based on altitude. So here the problem is draw an acute angle triangle PQR. Draw all its altitude, means how many altitudes will be there? There will be 3 altitudes, okay, as it is having 3 sides. And name the point of concurrence as O. Fine. Now where the point of concurrence of acute angle triangle will lie? It will lie in the interior of the triangle, okay. So here we have to use the set square, right? So the set square, first I'll name the triangle. The triangle is PQR. Here it is P, Q and R. Fine. Now what I'll be doing? So I'll be placing the set square such that one of the perpendicular side of the set square coincides with QR and the other side lies on point P, coincides with point P. So here this is one of the altitude. The other altitude is, I'll name this as PS, RM, okay. And from Q I have to draw now. So from Q I am drawing. So it's meeting at point, what to name? I'll name it as A. Fine. So it is perpendicular over here, and wherever these are meeting, that is point O. So in this way you have to draw for this particular problem, okay. Now the next one is draw an obtuse angle triangle LMN. Draw its altitude and denote the orthocenter by O, okay. So here I'll name this triangle as L, M and N. Fine. L, M and N. Now for obtuse angle triangle, what you have to do? You have to extend the 2 sides of it. So I'll be extending this. So here I'll be extending further. Okay. And this side also I'll be extending. The extension is shown by the dotted line. Okay. Now the very first one is from LN. I'll be drawing first the perpendicular which okay, so this is one of the perpendicular. Then from LM I'll be drawing the perpendicular. So I'll be pulling this down and somewhere here. You have to be very particular regarding obtuse angle triangle, because one of the line, if it goes wrong, the whole thing goes wrong. Okay, and for this line, so this is LA, this is NB, this is M, C, I'll name this as D, and all are meeting at point O over here. Clear? So the problems based on altitude are done. In the next video, we will be dealing with the median. Thank you.